My name is Michal. I work for Tampere University in Finland, and in this video I will talk about HIPCL, which is a new tool created by our group for porting CUDA applications to OpenCL by using HIP. HIP is a relatively new language and runtime created by AMD as a direct competition to CUDA. It allows creating software which uses advanced features and full performance of NVIDIA and AMD GPUs. Unfortunately, it's still limited to those two vendors only. HIPCL is an attempt to bridge HIP to any device with sufficient OpenCL capabilities and find the limitations of this approach. HIPCL has some requirements on the OpenCL platform. The first is shared virtual memory. It is required because HIP supports pointers embedded in data passed between the host and the device. The second requirement is peer-v. Because the program using HIPCL does not know the OpenCL platform where the program will eventually run, we need an intermediate binary format, and we have chosen peer-v. HIPCL has been tested mainly on Intel's new OpenCL implementation for their GPU called Neo. It should also work on PoCL and Intel's OpenCL implementations for CPU, but some of the more advanced features like warp shuffle are not available. The most important parts of the HIP API are implemented with some caveats. The HIP event API does not map exactly to the way OpenCL handles events, because in HIP you create and record events yourself, while in OpenCL the runtime creates and records events internally. This is resolved in HIPCL. Unfortunately, some other limitations of OpenCL are more serious. HIP allows a large part of device memory to be allocated in a single memory allocation, while most OpenCL implementations limit the maximum allocation size to a much smaller value, usually a quarter or a half of the device memory. Another limitation is in the kernel launching API. HIP and CUDA allow passing all kernel arguments in a single array of bytes. This is not possible with OpenCL, which only allows setting kernel arguments one by one. There are some features in HIP which require an OpenCL extension to implement in HIPCL, and in some cases such extensions do not exist yet. One of them is that HIP API lets users to choose the synchronization method depending on whether the user prefers low latency or low CPU usage. There are also several parts of the HIP API which we did not consider critical for the initial implementation of HIPCL. This includes texture, symbol, and peer-to-peer API. The device code support is fairly complete with some exceptions. We use OpenCL device built-ins where possible. Shared memory, atomics, vectors, and almost all of HIP math library functions are supported. Warp shuffle functions are supported on Intel Neo platform with the Intel subgroup vendor extension. 16-bit floating point is supported with the Chronos half-float OpenCL extension. There is a large part which is missing, and that's device intrinsics with explicitly stated rounding mode. These unfortunately don't seem to be possible to implement efficiently with current OpenCL implementations. The overhead of HIPCL, unless using features that have to be emulated, is negligible. The main upside of the HIPCL approach is that CUDA to HIP code conversion is trivial, and compiling HIP code with HIPCL should ideally require no code changes. The downside is that some of the more advanced features are currently not possible to implement, or not possible to implement efficiently with the existing OpenCL implementations, so some code changes are still required. If you are interested in more details about HIPCL, contact us on our emails. If you want to learn more about what the CPC group is doing, you can take a look at our webpage. HIPCL is open source and you can find it on GitHub. Pull requests are appreciated. Thank you for your attention.